Welcome, this is an Excel AS Further Pure 1 Maths video. This is moving on to complex numbers when we've been doing that chapter for a while, but this is the roots of a quadratic equation. Now, you'll be saying, hang on a minute, that is so easy, we factorise it or use the quadratic formula. But we actually have to go back to the whole concept of complex numbers and how we come up with this imaginary number. Well, what happened is we took something like this and we said, okay, well, obviously we can't factorise this. Well, it'd be pretty hard to, unless you were a super genius, but, you know, don't want to show off my talents just yet. You use a quadratic formula, which was minus b, in this case is plus 6, plus or minus the square root of b squared, which is 36, take 4 times a times c, so that's 4 times 1 times 13, over 2a, which is just 2, and that is equal to x, and then therefore you've got x is equal to 6 plus or minus the square root of 36 to take 4 times 1 times 13, which is, so 4 times, so it's 36 take 52, which gives you minus 16, and that's over 2. Okay, and obviously you can't do root minus 16, so we said, okay, x is equal to 6 plus or minus root 1 times, minus root 1 times 16 over 2, so therefore x was equal to 6 plus or minus 4i over 2, so therefore x is equal to 3 plus or minus 2i. Okay, now focus on this. I didn't pay so much attention to it in the first video because I didn't want to jump ahead to this far ahead in the course. But that 3 plus or minus 2i. Now the plus or minus is in front of, and always will be in front of, the imaginary number. Now, obviously unless you've got x squared take root minus 1 x. Now that's highly unlikely and probably won't ever happen, so you'd have to worry about that. Now, this is quite a big and a long thing because it's saying 3 plus or minus 2i, and the plus or minus will always be in front of the imaginary number. Now the only thing that we talked about where the sign in front of the imaginary number changed, because that's essentially what's happened here, is we've got two different values for x, and the only difference between the two is the number in front of the imaginary part changes. So what we have there is x equals 3 plus 2i, or x equals 3 take 2i. And that's a complex conjugate pair, because we said a complex conjugate pair was a complex number that had the sign of the imaginary number in front of it changed. So it's as simple as that, and we just said it's a long wordy, fancy way mathematicians trying to sound intelligent and come up with this new word. So it's a complex conjugate pair. That's what quadratics will always be when you have a imaginary part to the x value. Now, let's say we didn't know this, okay? Say we didn't know that quadratic, and we were just given, okay, say they told us x is equal to 3 plus 2i. Say that's a root of a quadratic equation. Tell me the quadratic equation. Now, if you were in anything other than further maths, you'd go, what the heck? Well, you should do, because otherwise you should have taken further maths or have looked at it at least. Now, what we say is a complex conjugate pair is always the result of a quadratic which has an imaginary part to it in terms of the negative root, the square root. And a complex conjugate pair, remember, changes the sign in front of the imaginary number. So therefore, the other complex conjugate must be 3 take 2i to give a complex conjugate pair. Okay. Right, now what a quadratic, you have to really basic this. You have to think what a quadratic equation tells us. Well, it tells us the root of a quadratic, that one, for example, in this case. And what that's saying is, when you get something like x take 3, brackets x plus 1, we're told from is equal to 0, that tells us there's a root at x equals 3 and a root at x equals minus 1. So if we apply that theory to this, let's call this equation A and this equation B. Okay, so the complex conjugate pair is split up to one equation is equation A, one equation is equation B. And they're the roots, because we proved it using the quadratic equation, which we know shows us the roots. Basic maths, yes? Well, this is an enable us to work out the quadratic, by the way. So we know there are roots in terms of, when we said x take 3 is a root, then x equals 3 is a root of the equation. So using that philosophy, we call the first one A, then it would factorise to something like this. So x take the first A equation and x take B. Okay, and that equals 0, so therefore the x roots would be x equals A and x equals B. We said x equals A being the first root, B being the second root, okay? But you can come up with different A or B in terms of, at least you have the equations like that, whether the roots, okay? So, how does this help us to get to work out the original quadratic? Well, we just sub our roots into this factorized form. Okay, so x take A, and now instead of writing A, I'm going to write the actual, the equation that we said, this equation is A, okay, which is the first one. So it's x take, remember to put the brackets in there, x take 3 plus 2i, close brackets. Okay, and then it's x take B, which is x take the B equation, which we said the B equation was the second complex number, so the complex conjugate of the first. So it's x take 3 minus 2i equals 0. Okay, so we can put square brackets around that if you wanted to. So the next step now is it's working backwards really. So x times x, x squared, and then it's x times negative 3 plus 2i times x, so it's negative x brackets 3 plus 2i. Okay, so just explain it like you would a normal quadratic if you were working backwards. So we've done that, and we've done that. Oh, excuse me. And then it'd be negative 3 plus 2i times negative 3 take 2i, so it'd be plus, and then you just write the 2, so plus 3 plus 2i brackets 3 take 2i. Okay, so we've done that, and then it's just negative 3 take 2i times x, so it's take x brackets 3 take 2i, and that equals 0, because all we've done is expanded it, so it's the same equation. And then you expand them in individual terms, so you get x squared, and then it's take 3x, take 2xi, or ix, plus, now we don't just expand this, so 3 times 3 is obviously 9, and then 2i times 3 is plus 6i, take 6i, now plus 2i times negative 2i, well that's obviously going to be negative 4i squared, and as we know I is root minus 1, so we always say I squared is minus 1, so 4 times minus 1 is minus 4, so therefore instead of take away 4i squared, we're taking away negative 4, so we add 4. Okay, take 3x plus 2ix, or xi. Okay, so what will generally happen is the xi's will cancel, so you won't have any xi's, or you shouldn't. So this leaves us with x squared, it's probably the only one that's going to remain, we're not going to cancel down. Then you group together the x's, so we've got negative 3x here, we look across, and then we've got negative 3x here, so it's negative 6x. And then you just look at the numbers, so the real numbers, so that's 9, and then it's just plus 9. Plus 9 plus 4, so it's just plus 13 equals 0. And that is exactly what we had up here. So, wallop bazing, okay? We've got the number from the complex roots. How good is that? How good is that? Using basic C1 maths to make you look intelligent. That's pretty hard to do. Okay, so hopefully that's helped you out a little bit there. So I'll just recap that for you. Essentially what we've done here is I've proved to you that this is how we get this root going it this way. So this is a quadratic equation. We've started from this, factorise it out so you would if you didn't know what you were doing in further maths in terms of using the quadratic formula, because you can't factorise that. Obviously you'd get a negative root, and in C1 you'd go, oh, we can't do that, and give up. But obviously you're expected to be able to do this now. And then you take out negative root 1, it's I, and then obviously you square root 16, that gives you 4, and then simplify that, so x is 3 plus or minus 2i, and we said the root of a quadratic that has a negative square root is always going to be a complex number, and as we're going to give a complex conjugate pair, so therefore we use that idea of the complex conjugate pair. So a root of quadratic, say 3 plus 2i, the other root therefore must be 3 take 2i. So as we said, the quadratic equation basically factorizes it. So we put these two as factors, expand it out, simplify it down, got the original quadratic. So that's a brief summary of essentially what we've done in this video. Now, you don't need to use an official quadratic like this. You could come up with any, well, I mean, not too extreme, obviously, but you could come up with a range of different factors like this. I just came up with 3 plus 2i. It wasn't in a question at all. No, it generally wasn't, unless it's very coincidental. But what I'm saying is you can test yourself by just coming up with a factor like 3 plus 2i, so it is a real number and a imaginary part, so you get complex number, and doing the complex conjugate of that, so having two factors and just following this idea and testing out different factors and coming up with a quadratic and then working backwards using the formula to make sure you get the same idea. So you can sort of back yourself up in the exam if you get it wrong. Okay, so it's like one of them topics that you can double check yourself on. Okay, so what I'm going to do now is I'm just going to run through another one with you. So that question went through pretty much everything that you need to sort of go through really in this topic. I mean, sorry, in this roots of a quadratic equation. We are going to go look at cubic equations in the next video, but I'm just going to do another question. One sec. Oh, that's some good coffee. Right. Yeah. So, as I said, that was just sort of an overview on on the topic of finding a quadratic equation, solving them. So it sounds simple, but there's a little bit of a twist to it. Right, so what I'm going to do now is give you a root. So x equals 4 plus 6i. And I'm just going to give you a second now to pause the video and come up, tell me, that's one root of a quadratic equation. Tell me the quadratic equation, or if that's a factor, following what we just did before. Okay, so I'm just going to give you a quick moment now to pause the video and have a go at that before we go through it. Okay, alright, so hopefully you've had a go. Or if you've just been lazy, I praise you for that, because I do that quite often, so don't feel too bad. But if you've had a go, you're better than most of the other people probably watching this video. When I say most of the other people, I mean the other person watching this video, which would probably be me. So anyway, we said x equals 4 plus 6i, that's one factor of the equation. So therefore we said when we get a factor like this, the other factor of a quadratic must be the complex conjugate of this number. Okay, so that obviously says the other factor is 4 take 6i, because remember, a complex conjugate is just the same complex number with a sign changed in front of the imaginary part. Okay, so we said these are two factors, so we put them into the factorized form. Okay, so x take the first factor, so 4 plus 6i. Now obviously if you were to go through it the proper way that I did, say call that equation A, call that equation B, put them into factors, that would have been fine as well, but that was just really to get you going. But this is the quicker way. So, and the other factor is x take 4 take 6i. Now the key bits of these are to remember to put your brackets around the right parts. So you put brackets around 4 plus 6i and obviously brackets around the individual factors, and in this case put the bracket around 4 take 6i. So when you expand it out, you don't start messing it up. Obviously that equals 0. So then we just do the simple expansion. So that will give us x squared, and then you do it depends which order you expand it in. So I'll do negative 4 plus 6i times x, so that's negative x brackets 4 plus 6i. Okay, and then, sorry, it's, I don't know why, I always do it this way, I always muck it up. Negative 4 plus 6i times negative 4 take 6i, so that's plus 4 plus 6i brackets 4 take 6i, and then negative x 4 take 6i. That equals 0, and then it's just a case of expanding it, so obviously the x squared don't do anything with. Take 4x plus 6xi, which obviously we know is going to be countered by something, but still write it in. And then just expand the double brackets, so that's 16 plus 24i, take 24i. So that's, remember, 36, take 36, but that's take 36i squared being 1, so that's plus 36. So it always occurs that little thing, so just need to remember it. Take 4x plus 6xi. Okay, so that obviously leaves us therefore with x squared. The 6xi cancel with this one over here. The imaginary parts also cancel. And then you're just left with, next part is countering up the x's, so you've got negative 4x here, and then you've got negative 4x over here. So let's take 8x. And then you add up the real part, so you've got 16, 36, so 16 plus 36 is 52 equals 0, which is what you should have in the first place. Now if you want to check that, I'm going to say this isn't right, I'm going to look like a colossal idiot, but you get the idea. So you could check that by putting that in the quadratic formula. So remember it's minus b, which is obviously minus 8, so it's 8 plus or minus square root of b squared, which is 8 times 8, yeah, 64. Sorry, I want to make sure I'm not going completely insane, because I just like, I'm feeling, no, that's correct. Take 4 times a times c, so take 4 times, well this is going to be fun, times 1 times 52. So it's square root of 64 take 208. I was going to say this is incorrect. Oh, I'm going to like a colossal idiot. Over 2a, which is just 2, so that equals x. So 64 take 208 is negative 144. Actually, I think this might work. Might, he says, rather incompetently. So that is obviously 8 plus or minus the square root of minus 144, which is plus or minus 12i over 2. So that equals x equals 4 plus or minus 6i, which is what we got up there. What about that? That is just one that I've come up with, and it works. Okay, so everyone should work that you do. So obviously, so you can always double check what you've done. As I say, you don't need questions. You can just come up with your own in this context, because it's quite a nice one, really. All right, so thanks for watching. That's another question. I didn't want to do any more really, because that kind of covers it. And if you don't get it there, I will do some more questions. You're more than welcome to comment on this video, and I'll send you a question sheet of these type of questions. But and I will do another video for you personally. But it's quite a nice topic, that one. Just a little bit of getting your head round, really. There's a couple of stages, so I'll just recap the stages for you at the end. So what we have here is you start with a complex conjugate pair. Is always the roots of a quadratic equation as a negative square root. So if you're given a root that is 4 plus 6i, the other root therefore must be 4 take 6i. Then, because you know they are roots of the equation, therefore they are factors. So x take the first root and x take the second root is how you'd factorise it. Then it's simply a case of expanding and simplifying, and then you can do the you get the quadratic at the end. You can always go back and use the quadratic formula to make sure you've got the right roots. But that's sort of a double check really in case you're unsure, which is only if you've got a few minutes in the exam to spare. Okay, so thanks for watching, and we'll see you in the next video.